I'm gonna do it. I know better, but I'm gonna try. I'm gonna hold this, melt that, show. There we go.
Today's Captain's Blog is made possible through the support of the great and wonderful Robert Lopez. Thank you, sir. For anyone else who's interested in getting involved deeper and joining the Discord and exploring the world of electronics, check out the links below in the description and see how you can get involved. Thank you.
Hi there, guys. Welcome to Electronics Episode 3. I'm Chris Boden. You're not. Be happy about that. So, in this episode, we have the Velleman Brain Game Kit. This is kit MK112, and today we're going to learn a little bit about diodes and resistors and microprocessors. This is actually pretty cool, and I'm genuinely excited about this. So this is our board right here, and it's really simple. I think this is going to end up with like a Simon type game for all of you 80s kids out there. And I like this because it tells us, if you look at the instructions here, this is step 1, resistors, and it says R1 through R4 is 470, just 470, not 470 ohms, not 470K, but it tells us yellow, purple, brown, and things about pairs and stuff, but yellow, purple, brown, and we know that it's R1 through R4, so there's 4 of them, and we know we've got 2 resistors that are 4K7. What does 4K7 mean? 4007? But we've got 2 of those, and we've got one, R7 is just 47. So, and we know that we've got 4 that are yellow, purple, brown, 2 that are yellow, purple, red, and 1 that's yellow, purple, black. So it's really easy in sorting them out. Here's 4, and they're all hooked together, so I know that that's R1 through 4. 2 more. Now my problem with these, especially if yellow is the first one, is knowing which way to flip the resistors so I can see it right. So it's just figuring that out. I gotta hold those down closer to there to be in focus. Sorry about that, guys. It's a new set! I'm still learning how to do this shit! And then there's one that's different. But resistor color codes are like, that's my hard part right now. So we're gonna put R1 through 4 in here, and these are neat. They come right in the dingus. So we're gonna start with R1 through 4. And I want to thank everybody who's been commenting on these, because wow, am I getting a lot of comments on these videos, because it's weird. I'm used to doing, like, most of my life I've done videos on like high voltage stuff, and people comment on them, but there aren't a lot of people, you know, comparatively in the world that really get to work with high voltage in the way that I do. But with the electronic stuff, there's a lot of people that do this, and they know way more about it than I do, and that's super cool. Like, it's really neat that I can make videos like this, and when people comment on them, they're teaching me things. Like, I got guys like, oh, you want to set your soldering temp to this, and here's why. And it's not just, oh, you're an idiot, you set your soldering temperature way too high. It's just like, no, man, here, this is, you know, your tip temperature has to be this to get the transfer through the thing, and you know, if you can't get it to stick right, you can add a little bit of flux and do this to it. And like, it's really cool that I get to post videos and there's people out there teaching me stuff, and I really appreciate that a lot. I like that you guys are getting involved and helping me to learn new things and get better at this, and that's just makes my day. I really like it. So that's R1 through 4, and R5 and 6 are the 2 different ones. Those are the 4K7, so this is 5 and 6, and I see 6. Where the hell's 5? Everybody right now is yelling at their screens going, it's right there! Oh, it's over here. Okay. And this is 6. Now resistors are cool. I'm going to try and teach what I can in this, but for most of this, I'm the guy learning this. I think resistors are cool. For those of you that are kind of new, Resistors are the most passive of the passive components. They bring nothing to the game. All they do, like all a resistor does, is turns electricity into heat in a rather precision way. And they are 100% efficient at what they do. Are you guys all going to stay there? Alright, we can turn that over. So our tip is heated up to 750 degrees because I only have an up and an enter button on my soldering iron. I got to figure out how the hell to bring it down. I have a Hakko FX, what is it? 888D, I think. So I'll bet there's a manual for that on the internet. Alright, so we're going to tin our tip. Oh. I got to get a fume extractor from a soldering iron. That's the thing I need. Get in your hole. There you go. See, that one took too long. I don't like spending that much time on one because I'm scared of cooking things. Now with resistors, you really can't fuck it up because, I mean, it's designed to get hot. What's the worst you're going to do? I'm going to flux this board a bit because I'm not getting the... my things are too bulby. I want less surface tension. I don't really think I need to flux. I think this is more of I'm an idiot and I'm doing something very wrong. But when in doubt, flux the shit out of it. If you don't know, and it's not like I'm going to hurt anything, I don't really think I can have too much flux. Oh shit. Stay up there. Have people like, don't bend your leads over so far. Alright. It works for me. I can clip them off. Mouse is getting pissed about the lead. She's like, man, my students can't bend their leads over. I was like, well, your students can't solder as good as I can. I got skills. I'm a fucking genius. Alright, now let's try this and see if we can suck at it a little bit less. Oh, that's way better. Instantly way better. Ow, fuck, that's hot. Okay, so we can't touch the bottom while we do the thing. So I'm bending my leads over more, and you guys can kiss my ass. Because I'm sure as hell not going to push the resistor back up towards the board again. That was a lesson I just learned there. To the guy who commented about me using the bigger tip, I got some tips in the mail, and I'm gonna be changing that around. Yeah, I need a fume extractor. This stuff can't be good to breathe. I don't want one of the little desktop fan ones because it's gonna make too much noise on the mic. I want to get one where it's like a remote box with a tube that comes up onto the desk. And it's got to be quiet. It's actually an important thing for me because I endeavor to get you guys the quality audio, the best audio. I want you to have basically electronics ASMR. Okay, now those two are not... Wow, it's really cool to be able to look at the Z-axis camera and be like, wow, hey, look at that shit. I understand why a lot of electronics guys work with a magnifying lens. And I got pretty good eyes. Alright, we're going to set all the little things not on the silicone mat because they're kind of a pain in the ass to pick up. I should get a little cup to keep on the table just to keep trash in. That is not a bad idea. Get in there. Okay. So, yesterday, I spent the whole day just overhauling the entire set. I tore the whole damn thing apart and added lights and moved things around, and we're on it. We have a different overhead camera now. I should turn that other light on. Let's see if this helps. A little bit. That's not bad. Yeah, that's all right. All right, so right off the hop, I got some shit going on here I'm not happy about. Let's clean that off better. There. Okay, and all our resistors are down. Oh, fuck. See, that's the one that tried to kill me. Alright. I'm gonna do it. I know better, but I'm gonna try. I'm gonna hold this, melt that, show. There we go. Just get your hole. Okay. Oh, if you're quick, it's not bad. Alright, so now we got R5 back down. That's looking good. R2's a little janky, but just, I'll live with it. Okay. So that's step one. We have 7, yeah, we have all 7 installed. Alright, so we got 7 resistors in. Step 2, we're going to learn about diodes. So this one's weird. We got 2 different diodes. One of them's a BAT85, and we can see with the polarity, we got a stripe on the diode and a stripe on the board. And then this one is a 1N4007. Now 1N4007, that sounds like a normal diode to me. This sounds weird. BAT85, I got BAT diodes? The fuck is a BAT diode? I don't know. Let's figure it out. So I got my little bag of parts here, and we'll just dump all our shit out. So this diode, that looks like a diode to me. Okay. And that's, I'm gonna guess that's the 1N4007, and that's D2. So that goes, oh, and we can see a little stripe? So it goes in that way. So we're just gonna stick that right there right now. Now I got, look at that. 0 ohm resistors. Huh, okay. We got switches, we got capacitors, LEDs. That's gotta be it. And it's got a little stripe on one end. So it's different. So I'm guessing this is the BAT diode. That looks, it's glass. It looks like a little germanium diode or a Xeneer diode or something like that. I wonder what a BAT85 is. Because it looks different. It's glass. But I do know that it's D1. Where the hell's D1? See, that's D2. Oh, over here, D1. Okay. So we'll fold this over. Now we got to make sure. See, we see the stripe. So that goes in that way. A diode is a semiconductor that will allow electricity to go through one way, but not the other. It's like a one-way check valve for electricity. And it's pretty much the basis for all modern electronics. The diodes are what makes it possible for us to have transistors, and transistors are what the entire fucking world runs on. Transistors are made of love and light and silicon, really. Alright, so that looks right. And this one's smaller too. So I see the stripes going the right way and the stripes going the right way. So we're going to flip these over. Grab my magic wand of electronics. Yeah, definitely got to get a fume extractor. Especially since the smoke keeps going right up into the lens. That looks alright. I'm amazed I haven't completely burned the shit out of this side thing yet. Okay. That. See, if I got a little bit too much of a Hershey Kiss on my solder thing, when I trim them off, I can just mow that shit right down. Alright, so we got diodes. That's step 2. Now, ooh, switches. Alright. So now we got switches. Well, that's easy. I can do switches. Do switches in my sleep. Now these are just they actually have a substantial click to them. These might be some kind of buckling spring mojo. Now the switches only fit one way, which is cool, because if they were square I'd be kind of screwed, because you'd have to figure out where the actual contacts are. But these just snap right down and in, so that's super easy. Oh yeah, I can do this all day. Switches get cool. If you start looking into the technical specifications of switches, you see things like, you know, rated for 1,000,000 cycles and shit like that. And these just stick down, so I don't have to bend any leads over. I really like that. We just solder that in. Ah, shit. Oh, the stream's muted. Give me just a second, I'll fix the audio. You can't hear me say that. Hey. Oh, when you watch the video, now you'll know that was the moment I realized that the live stream audio was screwed up. There, live stream audio's fixed. Sorry about that, guys, I didn't know. But you should have audio now. I want to say hi to Squirrel Nutty, Shortwave, Dan, Sparky, and Mr. Rickenbach was in here a minute ago. Alright, we're going back in. Mark! Alright, so the switches were super easy. Yeah. That's cool, and they all still work. Cool. Alright, so what's next? IC socket. Fuck yeah. I love socketed ICs. I love them in this context. Oh shit, my pin's bent way the hell out. Well, that's okay, because I have this really cool smooth jawed pair of pliers from Avitech. Thank you, sir. I love socketed ICs because it lets you do the soldering on the board and not have to worry about melting down the IC. It also lets you swap out the IC if it fails. Now, you can see the socket. I need a pointer. Hey, I'll use solder. You can see the socket has a little notch in this end, and there's a little notch here, so that's where pin 1 is. So we can just march that right over there and drop it in, flip it over, and then I'm just gonna bend a couple leads. Yeah, that'll hold it good enough. I might give it a touch with a finger as I do the first one or two. So can I grab it from behind, get the solder on top, thing on top. I'm practically Eiffel Towering this chip here. Okay, then we'll hit this one over here. So I've basically tack welded it in place. Then we'll go over here. If you're doing something that has a lot of solder joints on it, you want to move around. Oh shit, solder bridge! Oh, we fixed it. Okay, we're cool. I'm used to my tip being too small. Here it's kind of big. That came out really good. Yeah. Okay, so we've got our IC socket in. Next is C1, which is a 1 microfarad, by the looks of it, a ceramic disc capacitor. And then we're on to LEDs. So we'll do the cap first, because there's only one in the whole kit. That's easy. Where's it go? Oh, right there. Okay. There's no polarity on it. Drop that right in. Bend you out. Bend you out. Yeah. That's right. Okay. Quick and easy. Okay, so that's on there. And next is step 7, LEDs. We got 1 through 4. They're all itty bitty little 3mm LEDs. Now we can see the LED on here. There's a flat side on the circle. The flat side is the side of the circle that's cut off. So you use the lead that's cut off that goes in there. And when you drop it all the way down, that side of the LED is usually got a little flat on it too. The cut off side has a little bit less, and a little bit less you get there through subtraction, and subtraction is the minus, and minus is the cathode. So that's how you know. Alright, so that's all 4 of those. Oh shit, this is hard. So I've come to realize something that I was not expecting. I actually enjoy soldering. I'm not sure how I feel about that, but I actually enjoy soldering. Oh, this is tight. This is fucking tight. I'm gonna play hell not solder bridging those two, so we're just... I got an idea. I got a plan. Just a tiny bit of solder. So 3mm LEDs suck. That's what I've learned here. Okay. Well, those aren't touching, but there's more solder on this than I'd like there to be. So I'm actually going to take a little bit off. Okay. So what I'm going to do is I'm going to cut this lead, the soldered lead on these. Just get it the hell out of the way. That'll let me get a tool down in there. If you see me making some weird hand contortions like this shit, it's because there's a lens right in front of me. And sometimes I have to get a little creative to get in there. Alright. So I'm concerned about a solder bridge here with those. Now that's... what the hell is that? Is that... oh, it's one of the... it's the resistor. It's probably electrically connected to it anyway. That's probably a current limiting resistor for that. Yeah, I think those are connected. I'm not going to worry about it. I think those are connected. This side, however, definitely not. That gets fucking tight in there. Alright, I think we're okay. There's that little tiny haircut. That look okay to you? Looks okay to me. Yeah, it'll do. Okay, what's next? So we've done our LEDs, our capacitor, transistor, T1, Bravo Charlie 547. It's going to be that one. Where are you? Oh. It's going to be that one, right there. So transistor, and then the LS, loudspeaker, which I don't think is a speaker. I think that's a piezo element, but we'll see. So transistor first, and the transistor is clearly T1. We have a flat side, so that's easy to figure out. So we just spread this out a little bit and bend that towards the round. And then for putting that in there, back one first, then the sides. Press it down. Okay. Got that. Got that. Got that. Okay. Now, transistor is just an electrically controlled switch, but you can do some pretty cool stuff with them. All right, step 9, LS1 TV3. What do these things mean? Like, LS1 is probably loudspeaker 1 on the thing. Now, this has 2 different length leads, so I'm going to assume that that's positive and that's negative, because the cathode is, so far in my experience, if it's shorter, it's the cathode. I can only bend one over, so we're just going to call that good. It seems to be hanging there. And the leads on that are so short, I can only really trim one off. Okay, so now it's got what looks to me to be a piezo buzzer on it. Looks like a piezo buzzer. Seems like it. Alright, what's next? Batteries. Oh, we're bolting things on. Alright, so we gotta bolt on the battery pack and then solder a couple wires. We can do that. There's 2 holes there, there's 2 holes there, there's 2 big pads there. But, hang on a minute. I got 3 batteries, but on the bottom, the leads are off on the corners. I got a lead off on this corner, and I got a lead off on this corner, and this wants them to be side by side. Did they change the packaging for the battery thing, or do I just run a wire way the hell over there? So this one here is off the negative end of the, it's a spring, it's a negative end of the battery. So this is the positive end of the battery, and we can see the jumper takes it over and over. So the batteries are all in series. So we have 3 batteries, they're gonna be 1.5 volts each. So that's 1, 2, 3, 4.5 volts total. Now we've got a big minus pad here and a big plus pad here, and that's the minus side of the battery. So I think we just run a wire from here. Oh, that is all dumb, no matter how I do that. So I think it's 2 wires off the battery pack to here. And we don't have any wires. And they tell us nothing at all. They want me to do that, but that's only 2 of the 3. Does this work on 3 volts? We're gonna test it because I think, like, I can do that. There's a little metal dingus there, and Alright, so it wants us to do it off at 2. Like, the picture's very clear on that. So we just wouldn't use the third battery. And that's a plus, that's a minus, so we'd have to solder off there. But those are bridged internally on that side. Like, because I got a plus pad here and a minus pad here, but they're bridged here and they're not bridged on this end. But if I flip it around, now I got a minus, so this is not good. These are bridged on this end, so I could get this end in and just ignore this and solder here to here, and that's close enough. Yeah, we'll give it a shot. Okay, I think I can make this work. It's kind of fucky, but it's like a $10 kit, so I'm not expecting the pinnacle of mechanical engineering in this. But you know, it's cool to get to do interdisciplinary stuff. Alright, I'm not prepared for this! Alright, we're gonna take that right out of the scene for a minute, and we're gonna do nuts and bolts. So that has to go like that. Okay. And then we gotta get that in there, like so. So now we use the serrated ones. And we get that to line up. Well, at least their fucking holes line up. Alright, cool. Okay. Well, now we're getting some progress. That's not fucky at all. Do I have a screwdriver small enough to get in there? Will it take a number 2? Yes, it'll take a number 2. Okay. So that's what the 2 0-ohm resistors are for, is the lead wires to get from the battery box down to the board. Also, gotta remember to put a one of my little 301 Klein adjustable screwdrivers in there. Alright, so we got our board back, we got our battery under it. It is securely physically attached. Now our battery leads come off this end, and we need a minus and a plus, ostensibly only 3 volts worth, because if you look at the thing, that's 3 volts. That's the middle one and one on the side. So that's what I'm going to do. I'm going to follow the directions even though it feels wrong. So I just got to run one from there and one from the middle down to there, and I can do that. Let's grab our clamp back. I'm going to do it on the end. What the fuck? Fuck! Ah, shit, I popped a switch right off. I must not have soldered that on there. Ah, shit. Alright, we're going back like 5 steps. How did I miss that? Did I get so caught up in shit that I just skipped soldering an entire switch on there? Oh, this is a pain in the ass. I really wish I'd have noticed that before I had to get out of my way. Before I had to fuck with the whole screws and the battery thing. I think we're going to test this with the power supply and make sure I'm happy with the voltage before I try and solder, bolt, fumble fuck my way around with the battery compartment. I'm gonna make sure this will work on 3 volts before I pick that goddamn fight. All right, so we'll just set all our hardware over there. We'll put this back in the stand. Let's make it work in a testing situation before we go bolting shit on the back. And I think we're very, very close to it just working in a testing situation. Find my damn switch. All right. So switch 3 just fucked right up. Yeah, I didn't solder that at all. You could have told me about that. I didn't even notice it. Why didn't you comment? You could have commented because you know that's how this works in real time. All right, let's solder that on there. Okay, is good. Now I have 4 switches on there. And according to instructions, the next step after the battery nightmare is plugging the IC in and then starting it up. So what I'm going to do is I'm going to grab a pair of power leads right here. And I'm going to fire up my awesome power supply. And I'm going to set it to 3 volts. And however many amps it wants. Melt it down. All right. So we got to put our chip in. Now our chip, you can see. No, you can't. Now you can. You can see the chip has a little notch on one end, and I remember this had a notch on the left. So we're gonna take our chip out. Now the legs on the chip are splayed out a little bit. So I'm going to grab my big fat flat pliers and I'm going to put this down on the bench and roll it a little bit like that. I can't really show you doing that. We're going to roll it just a little bit and bring those legs in. That trick was taught to me by Sparky Projects, and look, it works. See, now my legs are in a little bit so we can line them up into the holes. Make sure we're not missing any. Oh, we actually got to come out of here. So this chip is actually like a little 4 megahertz brain. Like it's a tiny little computer. All right, it's in there. Now let's see if the damn thing works. Do I have to? Yeah, we're going to take it right out to test it. Set that aside. Alright, so that's our minus, and there's nothing on top that we're going to screw up. That's our negative terminal. And this should just power right up when I do this. Hey, it's blinking! It's doing shit! I have a Simon game. So my power isn't quite right. But it works, and I think it's amazing that something, I wasn't paying attention. I think it's amazing that something so simple, so cheap, is capable of doing this. Like, there's a brain in there, there's a microprocessor in there. Oh, I pissed it off. And how cool is that? This whole thing is running, this only holds like 512 instructions. It's a really, really simple brain. Now it doesn't say what the chip is on here, but my weirdo buddies and I looked it up last night, hanging out on the live stream, and this is a little 4 megahertz microcontroller that it's got like 30 different instructions to it. It only has room for like 512 at a time, but blows my mind that you can do this. And also, this totally runs on 3 volts, so we can do the weird jiggity-pokety thing with these. So I'm gonna sort that out once I remember which way I wanted it to go. Yep, I'm doing it like that. Okay. So I'm gonna put this together, that and that. This is actually pretty cool. Like, it's stupid, but it's cool. The only reason this is cool to me is because I made it, and that just makes my day. I made a thing. So if you want to know the details on the microprocessor on this, if you check the chat off to the side there, you'll see Sparky Projects just said that it's a 12F508, and that sounds right to me, and he would know, he's a smart guy. And we looked this up last night, and I was just blown away because these things cost nothing. Pennies a piece, and they can do all this. And that's what has me excited about learning about electronics, is so much of this stuff is just mind-blowingly cheap. Like, look what you can buy a Raspberry Pi W for now. And those are one of the big fancy things. You know, it's a Raspberry Pi. Like, yeah, you can get the bigger, beefier, like the various numbered models of Pi. And they cost a couple bucks, but they're still super cheap for what they are. And then you got little microprocessors. It's a 4 megahertz microprocessor, and it costs like 6 cents. Okay, that just, man, blows my mind. So I got these 2 wires left, and I'm pretty sure these are for doing the power feeds. So I'm gonna chuck this back in the vise. And see if I can't totally fuck this up. Alright, so we got to ignore this bridge here. We're going to go minus to here and plus to here and off to the back. So we're going to do the easy one there first. How the hell I'm supposed to hold this? I'm just, I got an idea. First, let's tin the shit out of these pads. Big old gob of solder on there. Solder's cheap, and I got lots of it. Big old gob of solder on there. Okay, cool. And I'm just going to lay this right on here. So the good news is that totally worked. The bad news is I just burned the shit out of my fingers. Fuck, that hurt. Okay, so let's do that over here, and this time we're gonna hold it with the little fucking pair of pliers, because that was unpleasant. Okay, so now I got the soldering iron in my offhand. Oh, we don't want, no, shit, we gotta go that way. So I'm gonna put a bend in that. Oh, there is no graceful way to do this. I solder like old people, fuck. Hey, I was concerned I was going to solder my pliers into there, but luckily I didn't. Okay. Okay, so that's as good as that's gonna get us. What that is. It's a bad plan and cannot be changed. Okay, so I can come, I think, I believe I can come right through that and pull this wire in, and it's a little jank. I'll allow that. It's a little jank. We're going to pull this wire through here. Pull that wire up through there. I'm just going to pull on that. And I'm going to call that good. Okay. It ain't pretty, but form follows function. That's not true. It should be pretty. You should do better craftsmanship. But this is just, if I really care about it, I'll go back and make it prettier later. For now, I just want to make it work. Did that? Oh, fuck, I should flux that. All right, we're gonna clean that out. Because that's not meant to be soldered to. Nobody ever planned on this. That might work, but I'm gonna solder the inside of it just to be sure. So we'll just dump a bucket of fucking flux right down in there. We've now dumped a ton of flux in there. And follow that with a gob of solder. Okay, cool. So that's in there. That's on top. Now I gotta trim this on the inside. And that gob of solder actually just became a battery terminal, which is fine. We're talking about like double A's here. All right. Now, as a result of this, that'll be a negative battery terminal there. So we'll put our negative battery on. And this will be a positive battery terminal here, so we'll put our positive battery on. And now, if I fire up the power supply, it works! Ta-da! So we made a thing that does a thing, and it works, and I'm happy, and that's cool as hell. It's successful. We have accomplished the brain game. And I'm gonna put batteries in this, and this is totally gonna be a desk fidget for like the next week until I beat the silly game. It's got like, you gotta check this out. So it's got, this tells you how to turn on. So there's level 1, which is like a baby. And then there's level 4, which has a legit pick of Einstein. That's funny as hell to me. I like that it goes from baby to Einstein. So we made a thing. We made the Velleman kit MK112, the brain game, which is totally just a Simon knockoff. But I think it's the first thing I've ever made that had a microprocessor. I'm pretty jazzed about that. A little 8-pin IC that does all of that with just a few passives and 4 switches. Like that's so cool. Build one of these. This is a neat one. Build this kit. This is fun. And you'll notice I'm not putting like affiliate links in the description or anything like that. No, it's like this is like $10. This is cheap. If you want to support the show, don't buy affiliate link stuff. If you like what I do and you want to support this, check out the links in the description and get in the Discord. I want you hanging out. I want you to be a part of this. You know, if you like watching me fumble fuck my way through learning how to solder, subscribe, because everybody out there who's watching this has either had all of these experiences themselves and they've had to learn how to solder and they've like burned their finger and don't hold the wire, and you've been through this. You know what I'm going through right now. Or if you haven't, you're going to. You're going to, and it's going to suck. But I'm having a blast, man. I'm exploring shit, and I'm learning about, like, I got to learn about the BAT 85, which, is that a xenium? Is that a germanium? Like, what fucked up kind of diode is that? It's in a little glass case. I don't know. I'm going to learn about it, though. So that's going to be a thing. We're going to learn about this stuff. We're going to explore it. We're going to make cool shit. And I will be back in the next episode where we're going to build another little kit. I don't know what. Let's find out. Let's see. It's going to be the cricket or the shake. No, it's going to be the shaking dice. Episode 4 is going to be shaking dice. I'm not going to shoot that today because I got to get off of here because it's 11:31, and in just about a half hour you'll be able to tune in live and check out the cool kids over at Your Dinosaurs Are Wrong. They're going to be shooting an episode at noon. They're going on live, and you guys can tune in and watch them live, and they're way more better at what they do than I am. I'm an idiot learning how to fucking solder. They're like talking about serious paleontological science and things, dinosaurs and shit. It's pretty cool. So you guys have fun. Thank you for hanging out with me on this dopey ass video, and I will see you guys next time. Thank you. Instantly way better. Ow, fuck, that's hot. Okay, how's my hair? I'm still ugly as fuck. Okay.